Hi everyone, welcome back. Last kind of topic in this unit is on describing location of data points in a distribution. So let's get into it. So I'm just going to explain this kind of topic using an ongoing example. And so this is the context. It's about Ryan, and he took a geometry test and he got a 60 on it. And so when you ask yourself, like, is that a good score, right? It depends on how the rest of the class did. Kind of like when we were doing that anchor activity on those basketball players, like, and you were figuring out their average, like, how do you know if your player has a good average until you compare it to the rest of the players? And so here's a list of all the scores that the class got in their geometry test. Okay, so we range from 55 up to a 93. Here's some summary stats. We have there's 20 tests, n is 20 people took the test. The average or the mean was an 80, the standard deviation is 10, and we got the min and the max, okay? A nice like summary of the data right there in a table for us. So we're gonna use that in our problems. And then what we're gonna talk about, and the purpose of this video here is to talk about two things. There are two ways to compare his test to the class, or like describe his location in the distribution, right? So Ryan here got a 60. And so the way we talk about his score and the way we compare it to the other scores is we use something called percentiles and Z-scores. All right, so two things we're talking about today in this video are percentiles, number one, and Z-scores. Let's get some definitions. Percentile or percentile rank, here it is. It is a percent of values in a distribution that are less than the individual's data value. So it is just the number of data values that lie below the data value you're looking at, right? So it's the percent of values that are less than. And so here is a box plot, right? We have our quartiles. And so percentiles align with the parts of a box plot. Let me get my pen out here. So we have, you know, quartile 1 over here, the start of the rectangle. Well, quartile 1 is the 25th percentile. 25th percentile. 25th P. The median is the 50th percentile, the median of the data. Wherever the median falls, you're at the 50th percentile, right? It's kind of like, you probably heard this word, like if you go to the doctor, I don't know, and they're like, oh, you're in like the 80th percentile for height. I mean, that means you're probably taller. Or if you're like, you're in the 50th percentile for weight, right? You're like average, you're like the median weight for people your age. And then quartile 3 over here is going to be the 75th percentile because, right, box plots split them up into 4 categories. We got 0, 25, 50, 75, and 100. And so those match up nicely with the percentiles here. So if you fall at Q1, anytime you find a value for Q1, that's the 25th percentile. Anytime you find the median of the data set, that's the 50th percentile. All right, so they align nicely with box plots. And so it's something we're going to be talking about, right? If you're the median, you're also considered average, right? There's the median, there's the average in a normal distribution. Here is your below average scores, and here is your above average scores. So percentile rank or percentile, we've probably heard this word before, maybe at the doctor's office. I don't know. All right. Let's cover Z-scores. A Z-score is a score that tells us how many standard deviations away from the mean a value falls and in what direction. Oh my goodness, so much stuff in there. What that means is it helps for a picture, right? Here's my picture. Let me explain it. We have this normal distribution, right? Here is the average score of a 0. If you're average, you're falling right here. And so what a Z-score tells us is how many standard deviations from the mean that a score falls. So if this is the average, right, let's say the average height is being 65 inches tall. And let's say you are 68 inches tall, so you're somewhere over here. What the Z-score is going to do is tell you, oh, you know, you're 1.3 Z-scores away from the mean in a positive direction because you're above average, right? You're above 68 inches, you're being, is 3 units taller than the average. So you're 1.3, maybe your Z-score is about 1.3. That tells me you're 1.3 standard deviations away from the mean. And so you can be away from the mean in either direction, right? Here, when you're taller than the mean, you're above average. But you could also be shorter than the mean. Maybe we have someone who's 60 inches over here. If I'm over here being 60 inches tall, maybe my z-score is, I don't know, negative 2.5. And that means I'm negative 2.5 standard deviations, whatever that number is, away or below here, below the mean. And so it's kind of telling you, where do I fall on this normal bell curve? Okay, always in the middle we have the mean. And then the z-score is going to tell you where you fall, either above the mean or below the mean, and how many standard deviations away you are specifically. We're going to see this all come together when we do some examples. There's formulas. It's very straightforward once you know the formulas. Okay, moving on. Percentile rank. How do I get rid of, oh, there we go. Let's do some examples with percentile rank. So we have those scores. We're still talking about Ryan and his geometry test, okay? There's a list of the 20 scores. And the first question is, just kidding, the formula is to find his percentile. We're going to do the number of values that are below you divided by the total number of things you have in your list. This is the formula. I would get this in your notes somewhere. So to figure out someone's percentile rank, you just take the number of data points that are below it, and you divide by the total number of data points you have in the list. So let's do Ryan's score. If Ryan got a 60, here's his score. Let's do pink. He's right here. And so the formula says to take the number of values below divided by the total. And so I'm counting there's 1, 2, 3 scores below Ryan, and I take that divided by 20 to get a percentile of 3 divided by 20 gives me, what, 0.15. And so his percentile, right, we don't want it as a decimal, we want it as a percent, so I just move it to the right to give me 15, or the 15th percentile. Let me write that TH. So Ryan is at the 15th percentile. Okay, we took the 3 values below him, we divided it by the total number of values in the list, we got 0.15, we multiplied it by the total number of numbers. Let's do another one. It says Amelia got the highest score. What's her percentile? So we go over here. Well, the highest score someone scored was a 93. So you need to count the number of data values that are below it divided by the total. And so if I know there's 20 tests in the list, I'm just going to do, well, has to be 19 below Amelia. So 19 out of 20 gives me, I don't know, you can do that on your own for the sake of time, gives me what, like 0.95. So Amelia's the 95th percentile. Actually, this is a good point because notice how she's not the 100th percentile. Amelia is the 95th percentile, even though she got the highest score. And it's something good to note because, is it even possible to be the 100th percentile? Pause and think about that. We'll talk about it in class. Another example. Ben got the worst score. What is his percentile? So we're over here. This is obviously false, but okay, let's say Ben got a 55. There's no people below him. So there's 0 out of 20. And anytime you divide 0 by anything, you get 0. So Ben's in the 0 percentile. And last one says Mason got an 82. What is his percentile? So we find 82 in the list. And then you count how many are below him. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mason got 10 people below him, and I know 10 divided by 20 is going to give me 0.5. And so Mason falls in the 50th percentile, which we also know is the median. And so Mason got the median score of an 82. Okay, some examples on z-scores. There's a formula, different from percentiles, obviously. The formula for a z-score is when you take your value, so whatever you scored on this test, for example, is the context here, minus the mean divided by the standard deviation. And notice how I gave you this table with, look at this, the mean is literally right there, and the standard deviation is right there, and I have the list of scores. So there's no really way you can mess this up as long as you know the formula and you know how to properly substitute, right? Let's do one. Ryan's score. Well, Ryan's the one who got the 60. Okay, so I take his score of a 60 minus the mean of 80 divided by the standard deviation of 10. Guys, it's as simple as that, right? We literally just plugged in the numbers into the formula. And so you're going to get something like what? Negative 20 divided by 10, which gives you a negative 2. And so having a negative z-score means you fall below average, right? It's like you're negative 2 standard deviations away from the mean. And that makes sense, right? The standard deviation is 10. And so if you're negative 2 standard deviations, you're negative 20 points away from the mean. And so the mean is 80, and that means Ryan's negative 20 away from the mean stands, right? He got a 60 on the test. That means he is negative 2 standard deviations away from the mean. Amelia got the highest score. What is her z-score? So we're over here at 93. She got a 93 minus the mean of 80 divided by the standard deviation of 10 gives me, what, 1.3? I'm doing this for the sake of time. You guys can do these calculations out. Ben got the worst score. Literally just plug it in. Ben got a 55. So 55 minus 80 divided by 10. I'm getting messy here. You guys can finish that. Leona got an 80. What is her z-score? And this one I want to actually do out because something notable happens here. Watch this. 80, right, is her score, minus 80, which is the mean, divided by 10. And I already know that 80 minus 80 is going to give me a 0. And so Leona's z-score is a 0. So she, if we think about the definition, is 0 standard deviations away from the mean. So if she doesn't move from the mean, that means she must have scored the average score. And then we look back at our average, it was 80, and Leona got an 80. And so when you have a 0 of a z-score, it means you are the average. You scored the average score in the test. Okay, and so that is good to note, right? Our z-score is 0. It can happen. It just means that you got the average, or your average, I guess. All right, having a z-score of 0. What do I got here? One more example here, I guess. Do I have time? Yeah. Here's a dot plot of 14 school bus drivers. Formula for percentile rank. This question says, what is the percentile rank for the driver that has a driving time of 6 hours? So I find the 6. There she is. I count up the number of dots below the 6. 1, 2, 3, 4, 5, 6, 7. And I divide it by the total number of dots I have, which is 14. And I'm getting 0.5. So person who drives 6 hours is at the 50th percentile, or the median, right? This next one says, what is the percentile rank for a driver with a driving time of 9 hours? So I find the 9th dot over here, and it's the highest, right? And so we kind of already hit on this when we talked about Amelia's score, right, being the highest, and like what percentile was she? Well, if this person drove the longest amount, there's 14 drivers, so that means 13 people were less than them. So 13 out of 14 gives me a percentile rank of, when I divide that out, I'm going to get like 0.93. And I multiply that by 100, which gives me 93rd percentile for this person driving for 9 hours. Right, and it's something to note, just like Amelia's score. This person had the highest dot on the dot plot, but we haven't reached that 100th percentile, right? And so I want you to I want to end here and have you think about the idea of is it possible to be the 100th percentile? Yes or no, and maybe why. All right, and we'll talk more about it in class. I think that is it, yeah. All right. Thanks for watching. I know I sped through that, but feel free to pause and rewind and take notes, get everything down. Last topic of the unit, so see you in school.